the wallet SDK and its functionality. The wallet SDK is being designed for developers that wants to empower their current existing wallet apps. So either you are a mobile app or either you are a web browser wallet app, you can integrate the wallet SDK in order to add the identity functionality. So what are the functionality that are made available through the wallet SDK in the form of APIs? So first of all, the wallet SDK lets you store and manage safely your cryptographic key and derive a DID from that. A DID is a decentralized identifier, is a global unique identifier that is used to authenticate yourself to the public. This follows the W3C standard. And on top of that, the wallet SDK provides a further functionality that is for anti-track that allows you to create several aliases starting from this DID. They are like deterministically and cryptographically derived from your DID. And basically, you can decide whether to use the different identifiers when you are interacting with other actors, such that they are not able to tell who's behind this identifier, and they won't be able to tell your interaction across different platforms. So that's how we provide anti-tracking feature for user through the wallet SDK. The second feature is that it allows you to fetch credential. So it allows the wallet to speak with issuer to authenticate yourself as an identity and to receive and fetch this credential inside your wallet. It allows you to safely manage this credential. So this credential can be stored locally inside your wallet. As we already said, these are not NFTs, these are not on-chain entities, but these are entities that live off-chain and are stored locally inside your wallet, inside your mobile, or inside your browser. And this can be stored and also deleted using the functionality made available through the wallet SDK. And lastly, it allows you to authenticate yourself when you're speaking with verifiers. So the authentication can work in following two different ways. It can work via zero knowledge proof or via selective disclosure. So let's take an example to understand what's the difference. Let's consider Credential that is storing the information of your credit score. And let's say this credit score is 80. There are two different ways that you can authenticate yourself in sharing this information to a verifier. If you're sharing a zero knowledge proof, you're just sharing the information that your credit score is higher than a certain threshold. Consider a verifier who's a provider. They might ask you to demonstrate that your score is higher than 50 in order to provide you a loan. You can provide this information using a zero knowledge proof. And in this case, they won't be accessing the actual credit score. Or in the other case, they might be asking you to show their credit score. They don't need the proof. They really want to know your credit score. And in this case, you can work with selective disclosure and only provide a single attribute of your credential.
Selective disclosure also uses zero knowledge proof.
So this is how you can share this information related to the credential to the verifier. Also, a further difference is in the channel that is used to share this information. This can happen off-chain. In this case, you are just speaking with the verifier platform in a standard way, so there's no on-chain interaction happening. And on the other side, this can also happening in an on-chain manner. In this case, this zero knowledge proof or selective disclosure are shared inside an on-chain transaction. These are sent to a smart contract, the smart contract developed by the verifier that wants to authenticate your information. So these were the tooling made available for wallet providers that wants to integrate the functionality of an identity wallet to their application following the W3C standard.